here starts and quickly ends your study in Chapter 5. Chapter 5, the two sections you are considering tie together what we did in Chapter 4 with probability to what we did in Chapter 3 with distribution. So the title of this first section, Probability Distributions. Mainly this video takes you about 10-15 minutes, and it will be about just the concept of what it is that you're looking at. What is this table? And it will also turn into a histogram. And so we'll spend a lot of time on just this concept, like I said, of tying these two probability and distribution ideas together. The second video will be about these two concepts, and also things that you considered in Chapter 3, mean and standard deviation, and whether or not you've got a probability that is considered significantly high or low. Those two things come in the next video. So the jargon, the language, the vocabulary. A random variable is a variable typically represented by X. That is a common letter to use for math, right? That is varying, has a single numerical value determined by chance. That's the random part. And what you are listing out in these tables for X, which is the first column, are what are each of the possible outcomes when you're considering a situation. So X represents each possible outcome, and it is numeric, so it can't be red, green, blue. A probability distribution is the probability of getting each of those possible values of X. So you hear my language right now, you're just reading words, but you're going to have a table, and one side of the table is X, and then the other side of the table is the probability of X. What you're looking at in this chapter is a discrete random variable. And so discrete, going back to Chapter 1, is something that's countable. And if you can infinitely count, there's going to be some kind of formula, but what you're looking at is a table that it will not go on infinitely. A continuous random variable is something that you'll consider in Chapter 6 when we start looking at normal distributions. But in this chapter, you're still kind of stuck in probability land, but it will go quickly. As I mentioned, there are only two sections that we're considering. So in this video and in your homework for 5.1, the first set of questions are just, do you know what you're looking at? Presented with a table, can you tell me whether or not it is a probability distribution? And so these are the conditions. You don't need to know these as they are written or typed on this slide. I do want you to know that there are 3 conditions, but you don't have to understand this formulaic language. So basically, if you want to tell me whether it does satisfy a probability distribution, the very first column must be numeric and also discrete. So it has to be countable numbers, 0, 1, 2, 3. Secondly, the second column, those two conditions apply to what happens in the second column. That the probability of each of those is corresponding. And in order for a value to represent a probability, it has to be between 0 and 1. And secondly, in order for all possibilities to be included, when you add up all the probabilities, it needs to equal 1. Now, sometimes you're going to get, because of rounding, that it's 0.999 or 1.001, but it won't be anything like 0.8 or 0.7 or 1.2. And that will be the first set of questions that you are going to get in the beginning of this chapter, soon to be the end. Honestly, you'll be done with it by the weekend. So here is your example of how that is being tested. Take a look at this table and answer yes or no. Does this qualify? Are you being presented with a probability distribution table? Hopefully you answered no for a couple of the 3 conditions. First of all, this is categories. This isn't numeric, and these are not countable numbers. So that's the first reason why this is not a probability distribution. Secondly, when you add up all these decimals, it totals greater than 1, and so that's the second reason why this doesn't qualify. These could potentially represent probabilities, but they're not probabilities within the same set, right? They're different countries. So this is like 17% of all of the software in the United States, 70%, China, of all the software that is found in China. So that's why, even though these could arguably be called probabilities, they don't total up for the same group. So a common theme over the last couple of chapters is using childbirth and the number of children in a family to talk about probability. And what you see here is a probability distribution. X represents the number of female into birth, and the second column, if you add these all up, you get a total of 100% or 1.0 probability. What you see alongside the table is a probability histogram. Labeled on the side, it says probability, and then out at the bottom, it shows 0, 1, 2. Now, if you look at the video in StatCrunch, these are not connected. So not all probability distributions need to be histograms, but if you have a histogram, this is a continuous line. And so what you see in StatCrunch is that they don't connect it because you can't have, half of a female or 1.5 and things like that. So what I'd like to do now, it will take us a little bit of time, but I am going to ask you to do this on an exam, is try to come up with a probability histogram for 3 children. It'll take us just a little bit longer, but please do take notes. The process in itself is good for your brain and your understanding of these probability distribution tables and histograms. So when you consider a probability histogram, what happens first is the table. And when I look at the table, what hopefully you've gotten from this video so far is that the first column, it represents the number of something. And in this case, it's the number of girls in a family of 3 siblings or children. So X represents the number of female. And then P of X represents the probability that you will have that many female children. So if it's 3 births, all the possible things that could happen would be no girl, 1 girl, 2 girl, or 3 girl in a family of 3 children. To calculate the probability of that, I would need to know what the total possibilities are. And so if you're doing this quickly, you would do a chart that would have tree diagrams starting with first child and then second child and then third child. And then in your head right now, if you want to try to imagine the possibilities, hopefully you are thinking of just 8 possibilities. So 2 possibilities in the first births, 2 possibilities in the second birth. This is the multiplication rule. They're going to be 8 possibilities. Whether or not you're getting having a preference as to whether you do this tree diagram or just listing it, that is up to you. What you want to be able to do is correctly identify what is the probability if you have 3 children of having no girls, 1 girl, 2 girl, or 3 girls. So female, male, I'll use F and M to represent the first child. There's 2 possible outcomes if you have 1 child. If you have another child, there's also 2 possible outcomes, female, male, female, male. And then if you have a third child, which I did not, you would have 2 possibilities off of the original female-female family. You would have 2 possibilities off of the original female-male family. And so, if you have children, You know, that's always the question, right? Those big reveals, like, is it going to be a girl or boy? So female, male, female, and then I've been doing female, male, female, male. And so this 2 times 2 times 2 equals 8. They're shown right here. 1, 2, 3, 4, 5, 6, 7, 8. I put this off to the side because, again, when you're looking at these tables, we're looking at the decimal version of the probability, not the fraction. It could be fractions. I've got some examples of fractions, but so let's rock and roll. So this first family would be female, female, female. The next family would be female, female, male. Then you've got, so that would be all the families that had 2 females first. Then this would represent the families that had a female and then a male. So female, male, female, female, male, male. So, my apologies. I went to this branch. So I just listed these. Sorry. And then on that top one, I just listed these. Female, 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 male. Yeah. Okay, sorry. and then see, oopsies. It's like you choose one or the other. Try not to do both. It gets confusing. Sorry about that. Female, male, male, female, female. And then male, female, male. Male, female, male. And then maybe GB would have been better for me. I don't know. And then I'll do the 2 families that started off with 2 boys. And then it could either be 2 boys and then another boy or 2 boys and then a girl. Okay, so let's take a look at what would be the families that didn't have any girls. And that would just be this one out of 8. And so you just want to remember that you do 1 divided by 8. And you get the decimal. And because these are not, they don't go on forever, it's kind of nice when you're able to not have to round a decimal. That is exact. All right. And then let's look at the families that only had 1 girl. So 1 female. That would be this one here. This only had 1 female. That had 2 females. This one only had 1 female. And then this one had 2 females, this one had 2 females, and that one had all females. So when I actually found the one that was all male and there was only 1, that made sense because as you're branching it out, there's only 1 that has all M's. And symmetrically, and that's why this leads into normal distributions, you're also only going to have 1 possible family that has all girls. And so what you find is the 1 out of 8 and the 1 out of 8 are symmetric in your table. The probability of getting no girls having 3 children is the same probability as getting all 3 girls. And as I'm counting out the possible ways that a family of 3 could have only 1 girl, it's going to be the same number of outcomes that have 2 girls, right? So these 3 dots would be 3 out of 8, 3 out of 8, and that would total all of the families. So that's what I so love about math, even though you are listing a lot. Somebody did this for you, and you're trying to appreciate the formulas. Eventually the calculator will do a lot, but so that you understand this basic concept of probability and probability distributions, what they are, I am going to ask you to do this for yourself a couple of times on paper. And not this week, right? But eventually when you start preparing for a test, I will ask you to do this. Hopefully it will be familiar to you. 3 divided by 8 in your calculator would just be 3 times that. But 0.375, and this one's going to end up being the same thing. And so this grand total down here is going to be 1, right? The sum of P of X is going to be 1. So there you go. Hopefully you enjoyed doing that a little bit, and we'll move on to the next part of 5.1 in our next video.